Well, thank you. If you are listening to me now, you are here for Fast Prototype, Hard Reality, Agentic Engineering that Delivers. Um, and this is some of the latest information that I've gotten from going around talking to lots of folks in the life science space about how everyone's dealing with the AI agentic reality that we seem to be finding ourselves in. So, my hope in this next period of time is to leave you with some knowledge that you didn't have before. And so, specifically, um, myself and my team at MetaCell, we regularly talk to directors of R&D, CTOs, VPs across pharma, healthcare, research organizations. As we talk to folks, I think nobody is fully comfortable with the situation that's happening. It's evolving quickly. But what I'm going to try to leave you with in the time that you're spending with me, I know that everyone's attention is very split these days, but I'm going to endeavor to show you what I've learned and what we're learning at MetaCell about where AI is already winning, the early decisions that are defining the fate of various AI and agentic-based software projects. Talk a little bit about scientific user experience that drives actual adoption, and we'll be touching on production in regulated environments. And if you're just new to me, my name is Stephen Larson. I'm the CEO and co-founder of MetaCell. We have been delivering software to life science organizations for the last 14, 15 years. Personally, my background comes from both PhD in neuroscience and a software engineering background in production, as well as a computer science background. And I studied AI before it was cool. All the developments lately have been very interesting, but it's also given me the privilege of being able to distill what's happening in the landscape in a way that I don't hear from many other folks. So hopefully this will be useful to you. Please leave any questions that you have in the chat and we will get to them. Okay, so the landscape is moving quickly. This is Q2 now, 2026. It looks quite different than Q1, which still looks quite different than Q4 of last year. And I think the thing that makes Q2 look different than anything else is that we really are democratizing access to who can write code. So for the first time, we're seeing everybody being able to write code if they want to. The ability to build software is no longer a thing that only software engineers can do, or even people that have taken a Python course can do. And this is changing everything. This both creates massive opportunities and it also creates worrisome risks and a lot of urgency in getting it right. So we're hearing from organizations that we talk to, there's sort of a spectrum of approaches. There are the conservative adopters who on one end are sort of like, we really are not ready for everybody to start coding. So they're kind of like putting blocks in place, honestly, to ensure that that folks are not changing too much about what they're doing. There is a fear of IP loss, of data leakage, of regulatory exposure. So we're having folks firewalled away from using some of the tools that are really defining this era of agentic software engineering. And they're doing that not because they're never going to do it, but because they are evolving their internal policies to catch up with the technology. On the other hand, I've talked to lots of folks that are on the other side of aggressive adoption. They're tracking the AI usage across their teams. They're collecting metrics internally for who's winning, and they're sharing that and having conversations about success stories. They're running programs to enable people. They're giving people more tools, and then they're measuring what sort of productivity gains are coming from that. And then everybody else is kind of falling somewhere in between. Okay, that this is kind of the two axes that we're seeing. So, but it is clear that even in organizations that are trying to block this, that across the landscape, and whether people are admitting it or not, we have folks that are sort of showing up with systems that they'll show in a meeting and say, look at this. This is the thing that solves the problem that we've been talking about now for a while. And we think that that's both wonderful, and we think that that's also, potential cause for stress. And this presentation will talk about that. So obviously, the opportunity is to build tools from the people that need them when they need them without defaulting to expensive generic software as a service. Like, that's amazing, especially because there's sort of way more problems to solve than there are a SaaS product that can necessarily solve them. In our 14 years of building custom software, almost in a consulting capacity, to very large pharma, to medium-sized pharma, to very large nonprofits, we've seen that the defining challenge is how do you get exactly the software that you need when there's no product on the market that really fits what you want. So it's extremely exciting now that people can show up with a prototype that looks like it can do the things that are needed by the team. But the risk is that speed without some structure, we're seeing folks get bit, because once you show that thing in a meeting, now what is kind of the question, right? So how do you turn that early momentum into something that teams can trust, validate, and build on? So, this is from actually, what might be, a little too long ago, the idea from Gartner back in June 2025. But I do think that this particular report was prescient and could see sort of the writing on the wall, where they sort of said, 40% of agentic AI projects will be canceled by the end of 2027. And I think at that time also, I think the tools still weren't as widely adopted as they are now in Q2 of 2026. But I think the direction of what this was saying is still quite true. So, there can be, unclear business value beyond that one demo. There can be, inadequate governance. There's, an inability to integrate with legacy systems. So, legacy systems are a big deal, and a whole ecosystem that works nicely together in tune is really important at the organizational level. So the thing is, when an agentic AI project begins as a proof of concept or experiment, it's very promising, it's amazing, but it's sort of an N of one, and it stands alone. And how to make it work together with everything else is a challenge that very often an individual who brings it to the table won't have the full perspective on how to do that. So this is why Gardner was kind of saying that back in 2025. So, specifically, we see these things looking very impressive in week 2, but underneath the hood, we see things like fragile code with weak architecture. We see security gaps and fragmented systems. We see unclear ownership and poor usability. And then the net effect of that is really slow adoption. And for what we do, our main users are scientists who need to move quickly. And so the net of all those things is that you don't actually get the adoption, and you don't get the benefits from the software that you want. So we sort of heard a quote, like this, which I sort of anonymized, but the prototype looked great. Week 6 was a different story. So that early momentum is sort of masking some of these harder questions that are starting to come up about, validation, adoption, long-term viability. And so, elaborating a little bit more on that, there are architectural ideas and concepts that software engineers have been trained with that go beyond any particular programming language, and they go beyond typing on the keyboard every line of code. The typing on the keyboard is what agents are taking away from us. But the ideas, the architectural ideas, or the design patterns, or the fundamental underlying infrastructure of the internet, or how cloud systems work, all those things are still very much things that you will need to tell an agent to care about, or it won't, right? So in terms of fragmentation, siloing has been a problem for quite a while. Lack of data integration points is a general problem when an individual builds a prototype. And so folks that think on a systemic level are very often needed to solve that problem. And I'm going to talk more as well about security gaps, but there's, to name a few, HIPAA, GDPR, and then the cybersecurity situation that are very much a thing that often gets underestimated. And then finally, the adoption. So these things need to be considered from the beginning, and they are very often in a language that is not the language of a user interface that someone can quickly come and demonstrate in a meeting, right? It's the language of systems engineering, and it is the language of all the things that are very often the eat your vegetables part, the less sexy part of putting systems out, but we find that they are also the place where people can get stuck in a endless loop of tweaking a system that wasn't built correctly from the start. So getting these right at the beginning is a lot cheaper than fixing them when you get things at scale. So the regulatory environment really is putting, the exclamation point on this. Again, a prototype that looks awesome to begin with is, a thing that you can then add other prompts and say, hey, make sure this is HIPAA compliant for me, please. Right? Obviously, anybody can write that. Anybody who's has the idea to do regulated stuff can do that. But to truly adhere to compliance is not necessarily to follow a few of the pages on the internet that an agent has been trained on that defines what is HIPAA, what is GDPR, what does the FDA, say about this. It's also to be aware of a landscape that changes regularly, a landscape where the specific system that you're putting out to bear may not need to follow 100% of the requirements. It may only need to follow, 60 or 70% of the requirements, but which is the set that it does need to follow. Again, these are very often things that an individual may be unaware of, and that additional research might be needed or required to bring forward. The cybersecurity one is a particularly interesting one right now. With AI, it is now trivially simple for anybody to inspect a system that's just deployed to the public for any cybersecurity flaws that might be there, doing things that a human really would have had to really, really care about trying to put forward in order to, exploit a vulnerability in your system. But now that's sort of trivial. So you really need to be building systems with an awareness of all of the kind of incoming threats that are now, becoming much more prominent, and being able to speak the language of what those threats, could look like. What is a, injection exploit, for example? What is like a Stack Overflow? How does cybersecurity even work? What are the things that are usually falling over when a system gets hacked? Like, what does that look like? So that's knowledge that, again, is a thing that you can eventually get AI to tell you about, but is tricky when you haven't experienced it building in the way of software systems that has come before. Okay, so now I'm going to switch gears a little bit and just introduce some helpful vocabulary that we've been finding is useful for navigating this space. So you've probably heard of vibe coding, but you maybe don't really know what that is, or maybe you think that vibe coding is just any coding now that works with agents. And what I've been finding is a very useful way to define vibe coding is that it's what allows non-engineers to articulate what they want and have AI write code. Okay, so you get very rapid results. You're not really necessarily having to think about architecture. You don't have to tell it anything about like model view controller architecture, which is one very standard way to design a system to make sure you have a very responsive UI. You're not really thinking about the trade-offs that exist in a system. You're not really worried about them, because really what you want is to see things on the screen the way that you want them. And we now have the amazing ability to go to modern software, modern agents, and ask for what we want and get what we want out that like we can click on and that it works. Okay, the demo works. It's amazing. I've been super impressed by this, and it's really amazing. However, I want to contrast that with the second thing, which is agentic engineering. So agentic engineering is different, okay, because it comes together with that language of systems engineering that I've been talking about. Okay, it means that as you're talking to the AI, you're both seeing the impressive demo, but you're also exploring and inspecting the one layer underneath, which is, okay, great, but how did you build it? And what are the design trade-offs that you're making here? And that person is already thinking ahead to some of the concerns that we've talked about, the architecture concerns, the scalability concerns, the compliance concerns, that sort of stuff. And so they're building it in at the beginning. So with agentic engineering, right, you've got 10x faster implementation, but you've got visibility into those trade-offs. Okay. The constraints that are typically there when a system like this is going to get deployed are thought about from the start. And so, so the output is really reflecting not just the user stories, the use cases, but what the architecture needs to last. So what we're seeing is that software engineering is shifting from typing code to directing agents. So yeah, right, software engineers don't now, or less and less and less, really need to be writing 100% of the code. They're needing to write a lot less of the code. But the solutions at last, almost paradoxically, are still being built by engineers that are trained to think in terms of the systems, not just describe the features, not just describe a button and click on it, that kind of thing. So what anyone can do now is tell an AI what you want and get a prototype. But what engineers still are needed for, we're finding, is to tell an AI what the system actually needs and understand all the trade-offs along the way. And so that's where we're really seeing production grade software is living and what it's evolving into. So the vibe coding on the one hand, agentic engineering on the other. Okay. But what's exciting about this now is that as we're seeing this adoption happening, we're seeing small teams have much bigger ambitions. Okay. We're seeing engineers completing complex tasks significantly faster using these agentic tools. We're seeing a lean team, 3 moving like previously teams with 8 people, could move. We're seeing up to 40%, output gains with even larger multipliers for senior engineers. And so we're really seeing that folks that kind of get this and can move at the pace of agentic engineering are far, far, far more productive than software engineers have been, even just in Q4 of last year. It's really remarkable, the change that's happening here. And so then that brings me back to, okay, but why? So what is the point here? I've talked a lot about software for software's sake. But at MetaCell and over the course of our 14 years in this industry, we've really been focused on, well, what do you want to do, right? And what is the solution that you want? So the goal isn't just software that works, right? It's software that makes the science go faster, right? And that's what's really, exciting here, is the ability to improve our R&D cycles, to make better decisions at the bench, to get better insights, to do analysis faster, and therefore make more revisions and cycles on evaluating the outputs of research, and really scale up our ability to do discovery, essentially giving superpowers to researchers that they didn't have before, even a year ago. Okay, and what that can look like is, in the past, where there've been a ton of manual data wrangling across siloed systems, where tools were really built more for IT, but not researchers, where decision-making was sort of slowed by poor data access, you really now have the ability to get to AI-augmented R&D, right? Where you can much more rapidly build a system that's needed for what a scientist can do, have platforms that are designed around their research workflows, and just accelerate the entire plan, whether it's in preclinical drug discovery, whether it's in building a healthcare solution that gets to market faster. All these things are now very much possible to do in a way that we really haven't seen before. And it's extremely exciting. Extremely exciting. But again, we have to consider what it takes to get there. So for one of the things that we've been big proponents of for a long time, one of the things that's distinguished us as having a focus in life science as opposed to other shops that are out there that maybe can do all things for all people, is that scientists sort of approach data in a particular way. And a scientific workflow is different than, say, a workflow in civil engineering or a workflow in the entertainment industry. So when you're talking about science, there's obviously a language, a nomenclature, a set of concepts that are required. And so usability that is done alongside the scientist is really a critical part of this, a part of this workflow. In order to get that kind of speed that I've been talking about here, um, we really need to be doing this alongside those folks who maybe even are making the prototype or doing the first rev of the prototype, but carrying them along the entire journey of bringing a system to true production so that it can actually operate at scale. So we really can't skimp on the need to directly talk to the end users and the ones that are most scientifically knowledgeable about the data space that they're working to build. So we think about the following questions, okay? Questions to ask before you build. Could another team validate and and run this software without the individual who started it? Okay. If the answer is no, that's a problem, right? And that's going to be a problem for any piece of software that you have going forward. If you're a senior leader and somebody brings you a system like this, right, and then if you don't know how to hand that system off to somebody else that's going to be running it 6 months from now or 9 months from now, that's going to be a challenge. Secondly, does your architecture support the scale of data that you're going to want to use? So okay, great, here's a prototype and it seems like it can replace maybe a SaaS product that we don't like very much, or it can now be the core of a data flow that we've wanted to speed up for a long time. But if you're not sure that going from the initial test data set to the kind of scale that you want will work, then you're in trouble. So that's an important thing that catches people out a lot. A system that works for one person is not a system that works for 10 people, and a system that works for 10 people is not a system that works for 100 or 1,000. There are very different constraints that come when you start to scale that way, both in users and in data volumes. So those things have to be considered. And thirdly, would your scientists choose to use this if they weren't made to use this, right? And that's really where the scientific UX from the last slide comes in. We're finding that the best systems are the ones that are kind of effortless to use, that are obvious how to use, and that kind of usability comes from working directly with the users, not from the first time that you build it. So those are important things to think about. Okay, so another useful tool that may help you as you're thinking through this. So let's say that shiny prototype, shows up in your meeting and you're very excited about it. Okay, and you're like, this is great. Okay, so we would say, take these 3 steps in mind. Okay, in the first 45 days, audit it. Okay, think with the end in mind. Okay, go from the boardroom conversation to this is now deployed and people are using it. Okay, what are the risks here? How will the data flows scale? Who needs to look at this and weigh in on it? Who are the stakeholders that I need to build around this thing in order to know that this is really going to work? Okay, in the second stage, once that's established, you want to stabilize it. So you're going to want to go back and take that input and go back to that system. And maybe it's refactor, maybe it's kind of start a little bit from scratch on a slightly different foundation with an architecture that can scale. You want to establish the pipelines for doing continuous integration and continuous development. And you want to make sure that the compliance requirements are now embedded into that development process as you go through. And then finally, in the last period, once you've got those 2 things put in place, do rollouts with your teams. You want to co-design it with scientists. You want to run those tests, which means getting the feedback directly from the users, clicking on the screen, listening to what they have to say, and then making sure that these workflows are in fact buying people time and speeding this up. So this sort of structured transition is something that can be easy to ignore or hope that you don't have to do. But unfortunately, what we're finding is that people that don't do this, kind of get caught out. And that can be trouble. And that is why I think you see the stat that Gartner put, out there about the potential failure for lots of projects like this. So I think if you follow these steps, you're going to be more of a success story and not more of a cautionary tale. And so along that journey, then, just kind of saying it from a different, perspective, is starting with that prototype that you might make. Again, this is definitely not saying don't make prototypes, right? But it's sort of saying once you have that as your starting point, like do run it through these other reviews, right? Do the hardening work. Make sure that your adoption is a possibility when you get to the end there. And I think folks understand that, but I think that by following this process, you're going to have a much better time. All right. So then to kind of like put it all together in one picture, you might think of it in terms of three pillars. Okay. So, and these are kind of as old as time, really. These haven't really changed with the development of this agentic engineering approach. Okay. But at the bottom of the pyramid, okay, we think about architecture. We think about good design, modular design. We think about, what are the data sources and what are the flows? And we think about how is the infrastructure going to scale. One level above that, we think about all the compliance that's required. And we build that in to begin with. We don't, build it in at the end. And then finally, we think about, the crowning top of this, how is this going to actually accelerate R&D workflows? What problem is this going to solve? How do we know that? By talking to the users. And how do we track the adoption to make sure that in fact the scientist is actually accelerated by this process? I think with this kind of idea in mind, architecture, security, and scientist-centered delivery at the top, you're very likely to have success where others are going to fall by the wayside and fail. Okay, so that is my prompt then to now open the conversation up to you guys. I'm going to leave this here up on the screen, which kind of summarizes the discussion that I had to maybe help, jog folks, thoughts and about this. But this is kind of the picture as we have it. So thank you very much for listening. And now let's open it up for questions. So I see the first one here is a comment with basically someone validating the idea that, that designers, that folks that are working outside of the engineering industry are vibe coding to the user story, but engineers then can take over that prototype and make, real, secure, deployable, satisfying technical requirements. So yes, I absolutely agree. Thank you. Another question coming in. Is there any good resource for systems design for life science domain? Well, I think that on that, it really is, systems design for life science domain really is an intersection of two fields that only have so much of an overlap in the Venn diagram of sort of good practice. So I think on the one hand, you have, proper software engineering, which is a whole discipline in and of itself. Okay. And there's a lot of references there that are kind of as old as time. There's a book called Design Patterns that has been there for a while, which even when it was first written, didn't commit to any particular software language or programming system. It was just talking about, systems in general. There you'll find things talking about like iterators and factory patterns and to some extent model view controller patterns. So there's systems design in that way when we think about these underlying systems. And then other aspects of essentially like a systems engineering, curricula are understanding, the internet, how it works. What is TCP IP? What are ports that you connect to? What is the cloud? How does it work? When I'm running something on the cloud, where is it running? Right? And what is the stack all the way from the CPU all the way up to something that I'm looking at my screen? Where does the operating system come in? What does the compiler do? Okay, so these are all sort of systems design things that are important, maybe not at the prototype stage, but at the stage where you're trying to maybe get extremely high performance out of a system. Maybe when you're wanting to GPU optimize a particular thing. Okay, this comes into frame. And then the life science domain, right, is not about these things, right? In the life science domain, it's really much more about, well, what are the mathematical and computational problems that exist in the life science domain that we need to solve? What does it mean to do target identification? What does it mean if we're talking about computational chemistry to think about, how we model the way that a a small molecule might target a particular receptor, these sorts of things. So these two things, and in the healthcare space, it's like, how might I properly process a stream of electroencephalograph data? Okay, so these two things don't have like a single reference. I'd say that it's one of the reasons that I think we've been able to be helpful is that we kind of like overlap these two things. So I'd say though that if you want to understand about systems design, you'd start on the side of computer engineering and then apply that to the problems that are, of course, ever changing in the life science space. Okay, so let's see. Do you have any comments about the importance of thinking of building platforms versus apps? When we build tools, how should we be thinking of the overall infrastructure as opposed to tailored solutions for a specific goal? Aren't we all platform engineers now? Aha, yes. Well, that's the thing, right? So aren't we all platform engineers now? Yeah. I mean, so there's this thing called the Unix philosophy, which is still, I think, applicable and has been there as old as time. And the Unix philosophy comes from the idea of how, how the Unix operating system, which evolved into Linux, came to bear. But it was do one thing, build one piece of code that does one thing really well, and have that be a black box, and then chain together other pieces from there, right? So I think that philosophy is still really important to think about in this space. So I think the smartest organizations that we're seeing now that are adapting to this new reality are thinking about, okay, guys, we're going to build all these amazing systems, but please build it on top of a foundation where that foundation is these sort of Unix philosophy, do one thing really well, components, okay? What's really exciting is the possibility now for even in vibe coding to say, hey, give me access to all these components now that are existing inside of my organization, right? So that I can build on them in the way that my IT group wants me to build on top of them, so that I don't access the database directly as if for the first time, but I'm accessing it maybe through a framework or a library that, the larger organization has said, that's the way to do it. That's the right way to do it. So I think the Unix philosophy is still really important here. And so platforms versus apps, right? I would think that you want to have one group that's kind of responsible for that platform layer, that kind of infrastructure layer, which has kind of always been there. It's just not been accessible to vibe coders as much because they didn't exist, right? But you want one group that's thinking about that, because at that layer, you can also build in a lot of these compliance checks and that sort of thing. You can help to integrate with single sign-on, all that kind of stuff. And then this thing about apps, right? Then that might be the thing where, a prototype gets built, hooks into some of those underlying modular pieces. Awesome. But then even that probably, again, because the person who wrote it, if they're not themselves an engineer, then may hand it over to an application layer group who thinks about how to get that, up and running and working really well and seamlessly with the rest of the platform. So I don't know, depending on what your background and skill set is, I don't know that everybody is platform engineers, but we might all be capable of, taking what was like a manual human process out of our brains and encapsulating it in software, and then having a very clear description of what needs to happen, handing over to a group that then can productionize it. So I don't know. That's how I'm thinking about it. Okay, so next bit of feedback. Do you expect to typically build off of vibe-coded prototypes or recreate the idea from scratch to have control of the structure from the start? Yeah, great question. I think that depends very much on the ambition of the final system. So when I was talking about, think ahead, if the prototype is intended to be used for a limited purpose, say a limited blast radius, right? Hey, I built this thing and I think my team of 4 could really benefit from this, okay? Then you can probably take that code and build off of it, right? by injecting a few things into it, amazing. If it's for internal use only, for example, right, you might just take that prototype, do some refactoring, and build off of it. On the other hand, if that prototype is like, whoa, I think I have a whole new product line idea out of this, right? I think we can bring this out to our customers, right, and have them working in a whole new way. So awesome, a thing that can happen. That one, right, if you're like, oh, how many customers do you have, by the way? Oh, I think we're going to have about 5,000. Okay. You do not want to start with the vibe coded prototype and then just think you're going to evolve that. Okay. That's when you're like, okay, we now have a very clear set of requirements. Awesome. But now let's start a little bit. Let's take a step back. Okay. Let's think about that endpoint, right? And then let's work backwards from the several thousand users and what they really need. And then let's validate and see how what we have now can begin to approach that. Okay. Because that is a very different undertaking. And many of the things that may work super well, in that initial prototype will absolutely not work in that domain. So that's how I think about it. So you could easily build off a vibe coded prototype for a small blast radius, for a small team, for a limited release. You absolutely do not want to do that when you're thinking about going out, to production for a large scale engagement. Okay, let's see. We've got another great questions, by the way. This is awesome. I'm loving this. Please keep them coming. I'll try to answer as many as I can before the hour runs out. As agentic engineering allows non-coders to contribute significant pieces of software, traditional collaboration bottlenecks like code reviews are going to change. How do development teams adapt their collaboration and QA processes when code is generated by vibes and AI agents? Will we shift from reviewing syntax to reviewing intent and prompts? Okay, great question. And this is one of those things where, again, quarter by quarter, the answer is changing. Okay, literally Q4 answer to this question versus Q2 answer to this question, I think are quite different. And internally, we are very up to speed on the latest thing, and there's still just a fire hose of new approaches that are coming here. So I will give you, a thought or two. So version control is still so key and solid, even more important now than it used to be. The concept of version control. Okay. And so if you are a vibe coder who's not familiar with using things like Git or GitHub every day, right? This may not be a thing that you worry about very much, right? But I think that things like version control will be here. I think that's one that's going to last. Okay. That's going to be here for quite a while, right? As we're making this transition from humans typing to agents writing code. Okay. So the second thing that I guess I'd say is how will code reviews change? So I think that everybody's going to have a different level of comfort. Okay. I think that you can start to see some code reviews beginning to happen at a higher level of abstraction, if you will, which is to say, maybe your best engineers don't need to code review every single what's called a pull request, which is a way to submit code. If this is not your language, that's okay. But when a software engineer submits a significant amount of code, or even a small amount of code, they might do a thing called a pull request, which is a invitation to add or modify some features or functionality of that code. So I think what I'm saying here is that your best engineers may not need to look at every single code review in quite the same way. If there is not a lot of changes to parts of the underlying code that are core, maybe code reviews can be done a little bit more easily, because maybe it only touches some cosmetic change. Hey, if you're just changing, the color of a button or something like that, that's okay. Maybe you give your designers free reign, really, to commit directly to your staging area to make those changes, and you don't do so much code review at that level, right? But if you're talking about things that touch core functionality, if you're talking about things that have a compliance impact, if you're talking about things that have a performance implication, And when you're talking about systems that are more complex, okay, another idea that I didn't really talk about here is asynchronous programming, a thing that is a major feature of all modern software, where you have things that are happening out of sync from each other and needing to like match up later on at some point, right? When you have commits that are going to touch the way that all these things that are happening in parallel within your system might meet or touch, this is the place where classically lots of really weird and frustrating bugs crop up. And they are things that still like agentic AI can't magically solve for you. Those are just systems problems. Okay. So for those sorts of things, you really are still going to want to have humans look at the code and appreciate how that's changing the underlying system and how it works. I think one way to think about it is that senior software engineers will look at a code base and they might not think about it like a collection of lines of code. They're going to think about it like black boxes in a systems diagram. And so a code change that you're going to want to have your engineers review for sure is something that fundamentally changes the architecture of that system, that like adds a whole new box or removes a box or changes how the boxes are wired up together, right? But there might be things inside of a box that like optimizes a thing or two, which because it's in the box doesn't have so much of an impact on the biggest thing. And maybe some of those code reviews are going to be easier to kind of click through or kind of take AI suggestions for the purposes of speed, right? And so you are still going to realize the speed ups as a result of that. But at the same time, you're just not going to like let agents do free reign and let them do whatever. Okay. So there's again kind of the balances and some of the trade-offs there, which I think is going to keep being important. Okay. Great questions. Let me look here. Okay. More of a thought than a question, but I'll read it out. I've noticed that AI tools frequently fail with unpublished scientific data, as this data is not in the training data that the bot learns from. And this is frequent in life science as the topics tend to be incredibly niche, where lots of the knowledge is unspoken from meeting others in the field and not anywhere formalized. Okay. It's a thought more than a question, but I think there's definitely, a few that there's a few things I would like to, bounce off with that. Here, I'll stop the screen share now. Just kind of go back to directly speaking without that in the background. Yeah, I think that's a really interesting thought. I think there's a few things there that's interesting about this agentic AI future that we're, stepping into. Probably a lot of you are noticing that it's becoming easier and easier to capture conversations that you have with your peers or collaborators, whether you're using Teams or Zoom or Google Meet. Now we have all these built-in features where capturing what we say and having pretty reasonable transcription on what we say is easier and easier. I think teams are realizing the power and the value that's embedded in just those, what you might otherwise think are casual conversations. And what teams are also finding is that when they set themselves up to leverage the outputs of those conversations, it goes beyond just sharing the notes with the other humans that happen to be in the meeting, but it actually means taking and distilling the ideas that were there about the systems that you're building or the data that you're creating. You now can ask agents to, not based on the agent's knowledge, not based on what what we trained the AI to know, but based on what you said in a meeting, to say, hey, take all that stuff that we talked about and distill it into, a lot of things. You can ask AI to build a diagram for you. Hey, we were talking about a system. Can you whiteboard out the diagram of what we were talking about? And then of course you can iterate on it to improve it, but you can get some pretty good diagrams just out of interacting with the major AI agents once they're building on that transcript. And then you can also say, hey, distill a set of requirements for a product out of our conversation based on what we talked about. And it's very happy to write those things up for you. So yes, the topics tend to be incredibly niche. And then you say knowledge that's unspoken from meeting others in the field and not anywhere formalized. But the more of those conversations that happen in a room where there's a transcription happening means that organizations can now leverage a lot of that knowledge, build it up. And then when you get to the time where you're building the software, you could say, hey, I have 6 months of the meetings where we talked about building this. Can you run through the requirements and see if there's anything that we talked about in the last 6 months that we've missed? Like that's totally possible now, right? So that's a thing that I think organizations are taking more and more advantage of, and I think is a very exciting opportunity. So that's my reaction to that. Okay, next topic. So we got about 12 minutes left, so keep them coming. Any advice on testing these systems that were created with agents? How can we build fast without verification becoming an afterthought? Yeah. So I think this gets to um, um, some of the things that I talked about on the path to production in my earlier slides. I think organizations, again, are waking up to say, hey, I have a prototype, now what? I think what the organizations that are leading in this space are accepting that reality, inviting that reality, and then having a well-defined human process of evaluating the prototypes that are coming up and moving that prototype through a pipeline of evaluation, basically bringing it to other people, right? So whether that's being done right now through manager direct report relationships, where then the manager is looking at what direct reports are doing and saying, okay, I like that, let's promote that. I think what organizations are doing are saying like, hey, if there is the top like 3 or 4 ideas that you guys want to implement, like let's put that through now a process, okay? Take that vibe coded prototype and put it here. Okay, now we have this team that regularly evaluates all the vibe coded prototypes that are coming up, okay, for promotion to production. Okay, who do we want to deploy that to? Okay, is that realistic? Because then that's when the realities are going to start to get in there. So my advice on testing the systems that were created with agents and build fast without verification becoming an afterthought is to start building a process today inside your organizations where that is designed in from the beginning, that where we accept that people's ideas are now going to be expressed as code, but now we know what the handovers are going to look like, and we know the places where maybe somebody's great idea, they put it in practice and you failed fast. You're like, you know what, we tried it out, people tested it, it didn't really do the thing we wanted, but that led us to this other prototype, and now that's the thing that we really like and that we're using. So it's really the putting in of a human process. That's not necessarily an automated process, because at the end of the day, it's the human users that will give you the thumbs up or thumbs down as to whether that prototype is worth supporting into the future. Great question. Let's see. Should scientists look at multi-agentic solutions to work 100% for them, or should we set expectations to use as assistants or augment in their workflow for faster execution? You might want to clarify that one. But I think what I'll take away from that in terms of this question is, well, no, you absolutely should not, consider that any solution is going to work 100%, right? Although there are very real productivity gains that are coming out of, both vibe coding and agentic engineering, there's also a lot of pitfalls, that are still there. And so I think the power of the tool needs to be metered by an appropriate amount of caution. So yes, setting expectations around that are really important. Yeah. Okay. Let me see. All right. Here's another one. Recent agent definitions center on lightweight software like skills, and software is in quotes, skills plus agent definitions that lean into LLMs as a key component. Does the organization engineering design stack need to change for that type of system? Any recommendation about evals in this system? Yes. Right. So, yeah. Okay. So this concept of skills, you may have come across it the more that you might be investing in a more agentic tool that's coming out versus one that was typically more like you went to a web browser and you typed in your question and it kind of gave you a textual response. Over time, that started to look a little bit more like it could make maybe a document for you or that kind of thing. And this was the world circa end of 2024, beginning of 2025, even up to like Q4 of 2025, I think. And that's great. And skills are still probably going to play a big role, I think, into what happens going forward. Because what a skill is an instruction to an agent to do a thing that you've maybe spent quite a lot of time working on getting it to do it just right. And then you get to the end of that process, maybe like an hour's worth of work, and you say, hey, everything that we just did in this session, I want you to remember how to do that again next time. Please build a skill to do that. So if you haven't heard of a skill or what it is in this way, obviously there's the conventional definition of a skill, but an agentic skill is what essentially is another document that you can get an agent to write for you, which tells that agent the next time it goes to do that same kind of work for you to kind of follow a process that looks like this, okay? And that can be very valuable and can speed up lots of repetitive processes. Okay, the next time I need to, look across all of these, performance evals that I'm going to do, help me put, this feedback, front and center and format it in a spreadsheet that looks like this so I can see, the spreadsheet that's nicely formatted with bold, and I like to have the rows be this and the columns be that and all that. You can have a skill do that, and it can make the spreadsheet for you, and it can do that in a way that like an intern previously could have done that. Now you got an agent doing that. Okay, that's a skill. But I think here what we're talking about, we're starting to see is actually people going beyond just building of skills and actually saying, build me an interface. I want buttons. I want screens. I want things to scroll on and drag, right? And so there the question becomes, right, like I want an app, okay? And so I think that's a little bit different, right? Then the idea of an app with buttons and so forth typically is not just I want to use it for me, because otherwise I would just sit at the keyboard and just ask for it in a few lines. The idea of a thing with a user interface very often is I want lots of people to be able to do the same thing. And so you're sort of externalizing a process. You're like, I want everybody to be able to generate that spreadsheet in exactly the same way. And I want them to be able to put their own inputs into it whenever they want to, asynchronously. And so it's embodying that thing that was personal for you. So I think that the short answer is I think skills are very often tied to you and your preferences, right? Sometimes folks are experimenting with making skills that are shareable, right? And that's great. But then an app, right, is one step further of really sharing some functionality around maybe a visualization. You want to look at data in a particular way. You want to be able to turn data around in ways that are well defined. So that's like, I think, kind of a different thing. So an organization that will help folks take an app and make it available to a larger group, either internally or externally, is going to be thinking a bit differently than one that's enabling folks to make skills for themselves to do kinds of work that otherwise took kind of a long time. So so that's how I think about it. And then maybe any recommendation for evals in the system, the end part of that question just does kind of go back to my, to my presentation, where it's like, if you really want it, the more advanced production side of this that you go, the more that, all the compliance stuff has to be considered, all the, architecture stuff has to be considered, the scientific UX has to be considered, that sort of stuff. Awesome. Okay, so next question. Few people expect an agent solution. In other words, an agent which generates a summary from a database that does internet research to provide 100% accurate results. Was wondering what we should leverage to help them without 100% accuracy. So a few people expects 100% accuracy. Was wondering what we should do to help them without 100% accuracy. I think that the more context that you give an agent for what you want to begin with, the better answer you get out. I less and less rely on the agent to have the knowledge to build a thing internally. Instead, I want to compile the knowledge of what I want into documents that are well defined. And then if I'm doing anything like research or even asking it to like pull stuff out of a database, and then I want to give the instruction to the agent to reference my rather lengthy description of what the output should be first, and then maybe go to a data source or do some internet research, and only then give output that's based on what it's finding. So I much more trust agents to um, sort of parse things that I know what they are and that they're grounded in things that like I'm familiar with versus doing research. So I'll give you an example, right? And when it comes to scientific research, I would feel much more comfortable having an agent first find me research articles that that are peer reviewed and compile them into a document. Then have me go and pick out from say 20 the 5 that I've as a human read through and I believe in and trust, okay, that come from, good authors and that have good like method sections and all that that are well validated. And then as a step, say, okay, given these 5 papers that I like, okay, now please, go and, write me a process to do this thing, okay, like this drug discovery process or this healthcare thing or another research thing, right? Whereas what someone else might do is come to the prompt and say, hey, just write me a thing that solves this problem for me, please, using your best understanding. Okay. Those are 2 very different approaches, right? Where you know that the agent is like only going to use those 5 articles to start with. You're actually limiting its scope, but you're limiting it to a scope that's defined to you and is known to you. Then when the output comes out, right, then you say, okay, explain to me how you got that from these articles that I found. Like, how do you know that this is true? Cite specific paragraphs, point to specific, methods that were used. Okay. And then you do this kind of a validation. All right. So, this is how then you sort of like trust but verify, right? You go through this verification step where you're inspecting the output and you can still use the agents to do it, right? You can say, okay, show me how this part of your algorithm is related to what I asked you for. Show me how that part is related. And then you can like take in the whole output and read it yourself and think through it as a whole. Great. But you know what I mean? It's quite a lot different from not curating the input at all, and just saying like, build me the solution. I hope it's good. Right. So I would offer that as a process if you aren't already using it, as a thing that you can use. Okay. Amazing. We have hit the top of the hour. Really, thanks very much to everybody who has seen this. I hope this has been helpful, has been useful. If you've heard this and you think there's a way that I can be further helpful to you, please don't hesitate to reach out. We are very easy to find. I am Stephen at metacell.us. We'd love to work together with you on anything that you're thinking about going forward. I'm very happy to do a chat, at any time. If there's something that we can help you with as a company that comes out of that, amazing. But really, I think this space is just moving so fast that it's just helpful even for me to understand, what challenges or problems are happening out there. I'm always very curious, always happy to jump on a call. So thank you so much for listening, everybody. And we will see you soon in this fast evolving space.